Hello everyone, my name is Ayush. So in this lecture we are going to continue the last topic which we have studied about C++ variables and C++ comments. And in the last lecture basically I gave you an overview of what am I going to teach in C++, right? So in this lecture I'm going to teach about C++ data types and constants. Okay, so what do you mean by data types? Data types of what? Like if you remember in the last lecture I have taught you about variables, right? C++ variables, which are containers for storing data values. So these data types define the type of a data variable can hold. For example, like an integer variable can hold an integer data, a character can hold character data, etc. So you might be remembering I taught this before only, but just to uh, revise you this again, I'm going to do this once again. So what are the built-in data types? Okay, so these data types are predefined for a language and could be used directly by us. So the examples are integer, float, character, double, boolean. So let us go through them once again. Okay, so let me create a new file here. Okay, so let it be 2 lecture2.c. Okay, so let us start with this. So I'm including the header file first of all, and then I am also including the namespace, standard namespace, that is using namespace std. So I've now told you what are the type of data types which you can assign to a variable, right? So it can be an integer, it can be a floating point number, it can be a character. Let us assign the values right after declaration, right with declaration. So let it be 24, let it be 90.23, let the character be x. Let us define a string. String is what? So if you would have done C, then string, you might be knowing we can use an array of characters to define a string, right? So here we did not fix the size of the array to define a string. Like an array of characters to define a string, we can change this length. That is a very, very good or a plus point in C++. So let us assign it to be E encoders, right? So for the character, while assigning the characters, it should be within single quotes, and while assigning the string, it should be in double quotes. So it can be double also. The difference between double and a floating point digit is, let it be suppose z. Is that like a double data type can store more decimal digits, or it can store a more larger or more negative values. So like it has a broader scope as compared to the floating point numbers, but it occupies more size in the memory. So depending on upon your use, you can use either of them. Okay, so let us come back. So user defined data types, that are class, struct, union, enum, and then third one being derived data types, that can be array, pointer, function. This might be very confusing or very new to you, but soon I will discuss all of this. Okay, so let us come to the next slide. That is, first of all I will define what data types are possible. Like what most of the times we are going to use all of these along with a string, which I will discuss separately in another lecture. Okay, so first of all, what happens with int? Let us take a laser pointer. So let us take a laser pointer. So integer takes 2 or 4 bytes. So a byte contains 32 bits, right? Let me write it first. 32 bits. 1 byte. Wait a minute. I think this is not working properly. 1 byte is equal to this is not working properly. Okay, so let us write there. Okay, so 1 byte is equal to 8 bits, right? So this is the thing. If you would have already studied in your school level computer science or any other computer subject, you might be knowing this. This is a very basic and but very important thing. So 1 byte is equal to 8 bits. Okay, that this is the thing. Let us comment it out. And so we have seen there that it takes 4 bytes for an integer most of the times is equal to 32 bits. Okay, so the mac what how many values can this integer store? As we have seen, it can take 32 bits. So every bit can be 0 or 1. That is the thing. So it can store 2 to the power 32 values. Inside integer variable, right? Why is this so? Can you think about this? I have told you right now only. Because there are 32 bits and every bit can be 0 or 1. So there are 2 to the power 32 possibilities. Because, see, suppose let us take 3 bits only. Let us take 3 bits only. Okay. So the possibilities are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are 8 possibilities from 15. Did I miss anything? No, I didn't. Okay. So these are 8 possibilities from 15 to 22. So the thing is, this is the binary representation of all the numbers. So converting it into the standard decimal form, like the 10th base form, it will be 1. It will be 1. My bad. This will be 0. This will be 2. This will be 3. This will be 4. This will be 5. This will be 6. This will be 7. So I hope you have already studied about binary representation. Maybe in your like 11th or 12th class, or maybe in your school days only. I hope so you have studied. If not, you can watch some lecture online. Like those are very basics, the decimal representation and the binary representation. So these are the representation of 0 to 8. Since there were 3 bits only, so 2 to the 3 possibilities were there. That is equal to 8. But since in the integer variable we can store 2 to the 32 values, so this value, I don't know the number, but that is not important. But you should know the math behind it, right? So let us come back. Okay, so let me take a laser. So a floating point number stores fractional numbers, contains decimal places, right? So and the size will be 4 bytes. So it can store 14.23. It is same as an integer variable, but it can store decimals with decimal places also. And the difference between float and double, I have already told you that double can store more up to more decimal places, and it can store even more larger numbers compared to float, or even more like negative numbers. So like it has a broader scope as compared to other data type, that is float. Character can store a single character, letter, or a number, or ASCII values. And Boolean can store true or false values. Like it can either store 0 or either store 1. Okay. So let us move to the next slide. That are C++ operators. So like these are very important. Like this is like very important. I cannot stress on it much because it can put like some kind of a bad impact on my teaching, but like this is very important. I'm stressing on that. This is very important. Please pay attention on this. Okay, so C++ operators. So special symbols that are used to perform actions or operations are known as operators. So they could be both unary or binary. Let me show you that if what is unary operator, what is binary operator. Let us create a new file. Okay, so operators, lecture 2 operators. Let me write the basic syntax of a C++ file. So like this is the syntax of a basic C++ file. So let me tell you what is a unary operator. So let us assign int x. So the value of the variable here is while assigning the or declaring the variable is int x is equal to 0. And on line number 7, I am doing like first the meaning of this is x is equal to x plus 7. So this is a unary operator since this depends only on the value of x. But this is a binary operator since it depends on the value of both x and y. Unary means like 1 and binary means 2, right? So x is equal to x plus 7 can also be written as x plus equal to 7. And similarly, x minus is equal to 7 can also be written as x is equal to x minus 7. Okay, so this was the thing. So this is a very good example for understanding the difference between a binary operator and a unary operator. So this is a unary operator since it has only it is this operator requires only one operand, that is one variable, but this requires two operands, that can be two variables or it can be the same variable as well. Okay. So for example, the symbol plus is used to perform addition when you put in between two numbers. It is a binary operator. There are different type of operators. They are as follows. Okay. So it can be arithmetic operators, relation operators, logical or operators, bitwise operators, or assignment operators. So these are the types. So the first one being the arithmetic operators. So this can be used to perform mathematical operations such as multiplication, post increments, post decrements, pre increments, pre decrements, and many other things. Okay, so I've already told you of how this works. Let me open the file. This is the arithmetic operations file. Okay, I have kept it ready already. So the thing is, here I am doing like the basic addition part. So it is adding and printing it right after calculating it. I am not assigning this value to any variable. So that is the thing. And similarly, the subtraction part, multiplication part, and the division part. The new thing is this modulo part, like this percentage sign. So A modulo B means after dividing with B, what is the remainder left with A? That is the thing. Okay. So, and then here we encounter A plus plus, that is, this is a new thing to you. So, see, up to here, everything is like self-explainable, including this percentage defines the remainder left after dividing A with B. Okay, so here it is. So the value of A plus plus is, so what happens here? What do you think? So let us print the value of A and B here. So here A is 4, right? A is 4. Okay, so while doing this operation, this can also be written as a is equal to a plus 1. But this can also be written as a is equal to a plus 1. But what is the difference between these two on line number 13 and 15? The difference is that on line number 13, it first assigns the value, then after printing the value, it like the thing happens in line number 13 is first it calculates the value, it prints the thing, then it assigns the value. Means after printing the value of a, the value is assigned. But on line number 15, first the value is assigned, then the new value is print along with whatever operation is happening. So this is the difference between these two. Similarly here also. Okay, so here what is happening is, let me write it. Values are printed first and then they are assigned the new values. Okay, and here what is happening is values are first assigned and then the new values are printed. Okay, so I hope you would have understood what I meant by this. So like first the value 4 is printed, then the value 5 is assigned to the variable a. But on line number 15, the value of a is 4 before wait, let me print it and show it to you. See, before operation on line number 16, the value of a is 4, but like after performing the pre-increment or maybe pre-increment operator, pre-increment addition operator, it will increase the value of 1 before printing the value. So first the new value is assigned and then the value is printed. Okay, so this was a thing with assignment operators. You can read all of this. The only thing I think which can create confusion is this a modulo b, that is, once again I repeat, the remainder obtained when a is divided by b. Okay, and a plus plus and plus plus a, what is the difference? So in a plus plus, first the value is printed and then the value of a is increased by 1, and then in pre-increment the value is first incremented by 1 and then the value is printed. Okay, so let us move to the next slide, that is relational operators. Okay, so the thing is, if you are given two values x and y and you want to check the relation between these two, if x is greater than y, then okay, let us go to this. So this is the relational operator. So this will check, see on line number 7. On line number 7, this will check if a is equal to b. That is, if why are we assigning two equal to marks? If we assign one equal to mark, that is for this is for assigning the value, whereas is for checking if two values are equal or not. Okay, so if a is equal to b, then the value is assigned, then the newer value is calculated. That is, if a is equal to b, then it returns true. Like if that is true, then it returns 1, and if it is false, then it returns 0. Let us run this first of all to avoid any confusion. So since a is not equal to b, a is equal to b is false. Since a is 4 and b is 5, so it will return 0. But since a is less than b, then it will return 1. But since A is not greater than B, then it will return 0. So you are comparing if the relation between A and B. So that is why it is called a relational operator. So you can also check if it is greater than equal to, less than equal to, or not equal to. Let us check. Do not forget to keep bracket marks, otherwise it will create confusion for you, right? So this is the thing. A is not equal to B is true because 4 is not equal to 5, and A is greater than equal to B, that is not the case. But is A less than equal to B? Yes, that is true. So this is printed 1. So this was the thing with relational operators. So coming on to the logical operators thing. So, okay, let me define to you. So the thing is, yes, so logical operators are used to check whether an expression is true or false. I will explain it later what I mean by an expression, or like what if we generally use it in uh, if statements or while statements, but it would be really confusing for you right now. I will tell it later. So there are three logical operators: and, or not, and, or, and, not. They can be used to compare Boolean values, but are mostly used to compare expressions to see whether they are satisfying or not. Okay, so and returns true when both the operators are true or 1. It or returns true when either operator is true or 1. Not is used to reverse the logical state of the operand and is true when the operand is false. So what happens is, so when the value is not equal to 0, A can be a negative value or a positive value, then A is true. Okay, so that is A is 1. If A is 1, then A and B, where B is 0, will prove out to be 0. Since 1 and 0 is 0. Like you would have studied it in physics classes, I think in 11th or 12th class. But if you have not, then no worries. So and operator, how does it work? So on the left hand side you have an operand, and on the right hand side also you have an operand. So if both are 1, then it will print 1. Otherwise, if at least one of them is 0, then it will print 0. That is the thing. Okay. And what is an OR operator? So the thing is, if either of them is at least at least one of them is 1 or like a non-zero value, then it will print 1. And not A will reverse the state of like whatever, like if it is 1, then it will convert it to 0. Then if it is 0, then it will convert it to 1. Okay. So like, okay, let me write something. So nothing has changed in the really in the output. Why is this happening? So because 18 was previously 1, so it was already a non-zero value, and now also it is a non-zero value. So nothing has really changed. So the output is as it is same. But if I convert it to 0, then the output will change. As you can see, A and B is was already 0 since B was 0. But there are no ones right now. Okay, because both are 0. So the value of A or B is 0, and the value of not A, like you will inverse the value of 0, that is 1. Okay, so we are playing with bits right now. This is very exciting thing for me, at least, like playing with bits, because you're playing with only zeros and ones. Okay, so you should this will help you understand of how the things actually work in computer science, or maybe even in future purposes also, if you would like to pursue like masters or something else. Okay, so bitwise operators. So a bitwise operator is used to perform operations at the bit level. To obtain the results, they convert our input values into binary format and then process using whatever operator they are being used with. Okay, so this is the bitwise operators file. Okay, so this is the thing. Okay, let me close this file first of all. I think this is not needed. Okay, so the thing is, what are like bitwise operations? I hope you already know this. If not, then I will try to explain it first of all. So what is A and B? What is happening is, first of all we will write the bitwise representations of A and separately write the representation of B. So we are first of all ignoring the zeros which are on left hand side of both the numbers, since those will not really create any difference in calculating these values, but it will definitely create some difference if there would have been ones at the left side, right? So we are ignoring the zeros. So A and B, like what happens here? So we will see this particular bit where we have 1 in A and 0 in B. Okay, so that bit is what? Set in. What do you mean by set in A and or unset in A? So if that bit is 1 in A, we call it to be set in A, like the 0, first, second, and third bit. So we'll start from the right hand side and we will assign it to be this to be 0th bit, this to be first bit, second bit, and third bit. So third bit is set in the variable A and it is unset in variable B. So as I've already told you, like in the last slide, or maybe the last to last slide, that in using the AND operator, if both the values are, if either of the values are 0, then it will be 0. So here also it will be 0. But the second bit, both are 1, so it will be 1. And then it will be 0, since at least one of them is 0. And again, it will be 1. So if you write the binary representation of the result, so according to us, the answer should be 0, 1, 0, 1. So that is this. If you convert this to decimal, it will be 4 plus 0 plus 1. That is 5. Yeah, the result is correct. And similarly in OR, if at least one of the bits is set, then that bit will be set in the answer. And in XOR, like this symbol is called XOR. Okay, so in that using the XOR operator, if both the bits are different, like if one is 0 and other is 1, and or if the first is 1 and the second one is 0, then that will be set in the answer. Okay, and similarly with this tilde operator, it will reverse all the bits of the number. Okay, so that is the thing. And so this is a new operator to you, I think. Okay, so let me show you to you what it does. So suppose you have written the bitwise representation to be 1101. So this operator will remove the last two bits and it will right shift these bits. So the remaining number would be 11. If you convert it to decimal representation, it will be 3. So this is a right hand like let me show it to you the name, shift right operator. That is the thing. So it will delete the last two bits and it will shift the remaining ones to be to the right hand side, or whatever number you put here, it will delete that many number of bits. And similarly it is the left shift operator. So it will add two new bits whose value will be 0, and so the newer value will be 52. If you will calculate this value, it will be 52. Okay, so this was, I think, this would have been really easy if you have already known these bitwise operations. If not, then maybe you can watch this lecture again. I've really explained very well of how this AND works, and similarly the how OR works and how XOR works, right? And these two were new, so I have explained it from starting. Okay. So let us move to the next slide, that is assignment operators. So I think I have already discussed this, but let us discuss it once again. So yeah. So the thing is, first of all, I'm assigning the value 120 to the variable x equal to, the meaning is the RHS values is being assigned to the variable that is on the LHS side. Then I'm printing it. And then the meaning of this, as I've already explained it to you, that is x is being assigned the value x plus 40. And here, okay. So I think there would be confusion in this for many of the students. Let me explain it then. Okay. So first of all, on line number 9, the newer value is assigned to the variable x, that is x plus 40. So that can be written as x plus equal to 40. And if we are similarly using minus, then it will be x minus equal to 60 or 40 or whatever value you are using to be. But what is happening on line number 13? So the value which we have got on line number 12 is 100, right? As you can see, the third output is 100. But after printing on line number 13, the value which we are getting is 12. So 100 by 8 is 12.5. So why is it not printing 12.5 and printing 12? Can you think about this? You can pause this video for some time. What is happening? I hope you have paused this video and already thought about this. So I will explain what is happening right now. So the thing that is happening is this value x is an defined to be an integer. So it cannot really contain the a value of a decimal number. If you remember, then that is very good of you. If not, then that is also fine. So like it cannot contain any decimal point number or a floating point number. So it will automatically discard the decimal points and it will store only the integer value. That was the thing, simple. Okay, so and since the newer value of x is 12, that is being multiplied by 10 on line number 15. X into is equal to 10, that is x is equal to x into 10, that is 12 into 10, that is 120. Simple. Okay, so this was the thing about assignment operations. You can definitely go through these slides. We'll provide these, all of these. So coming on to the last slide, that is operator precedence and associativity. So it helps. What is operator precedence? If you had already studied, I think you should have been about BODMAS rule. That is bracket op. Then the next one was, I think, off. Then division. Then multiplication, addition, subtraction, and something else. Yeah, up to this only. So it helps us determine the precedence of an operator over another while solving an expression. So consider an expression a plus b into c. Now, since the multiplication operator's precedence is higher than the precedence of addition operator, multiplication between A and B is done first and then the addition operation will be performed. So the BODMAS rule was followed here. But in some cases it won't be followed, but in most of them it would be. So let us read this. Operator associativity. So it helps us to solve an expression when two or more operators having the same precedences come together in an expression. That is, it helps us decide whether we should start solving from start solving the expression containing the operators of the same precedence from left to right or from right to left. So you can check this link, that this is very, very, very helpful for you, I think. Right. So this is the thing. So you can go through this. This is very helpful. If you have any doubt, then maybe you can Google this, but I think there won't be any doubt. So this is the how the things actually work. What is the precedence order? So let me explain it using some example. Lecture 2 underscore ops precedence dot cpp. So first of all, I'm writing the basic syntax. So what is happening here? Can you tell me? So the thing is, what is happening here is, first of all, the brackets would be solved. So since the one will be solved first, that is x plus 4 will be 8, and here x minus 10 will be 4 minus 10 will be minus 6. So 8 into minus 6 will be minus 48 plus 10. So our value is correct, totally correct. So first of all, this bracket is solved, and then this bracket is solved. Then the multiplication comes into the order of BODMAS, that is minus 8 into minus 6, that is minus 48, and then 10 is added to it. So this was the thing about operators. Maybe after completing the control statements part, you can come back to this logical operators and relational operators thing. Then it will be really helpful for you of how you should compare two things that involve like the return type of a relational operator, or maybe use of a logical operator where we will use and or not. Okay, thank you.